Hello, today I will talk about my proposal and briefly explain about it. First thing first, you need to know about fiber break grating FBG. So what is FBG? FBG are special optical fibers adapted for non-thermal plasma reactors as sensors. They use ultraviolet light to change the fiber core's refractive index, forming a break grating that reflects specific light. Temperature and strain variations in the reactor cause the reflected wavelength to shift. So what is the problem statement? It's tough to measure temperature accurately in tiny plasma gratings due to their structure and the plasma composition. Current methods aren't precise enough. To address this, we aim to use FBG in the plasma grating structure, but need to improve methods to monitor temperature changes. The objective of the study is to investigate the effect of grating length on localized temperature behavior, and also to develop a method for measuring localized temperature in plasma gratings that uses FBG. In the scope of study, we use different grating length, which is 3 mm, 5 mm, and 7 mm. And then by varying the voltage, the temperature of FBG will be recorded. Not only that, the wavelength shift will also be analyzed and peak intensity will be measured to map temperature distribution. The FBG sensor detects shifts in reflected light. This shift is identified through the break condition. To directly measure this reflection, an optical spectrum analyzer OSA will be used. FBG sensor can be added to the dielectric barrier discharge DBD setup to monitor temperature changes. So what is DBD? DBD are self-sustaining electrical discharge with an insulating barrier, creating non-thermal plasma, also known as silent discharge. Let me briefly explain about the experimental setup. The FBG will be installed inside the DBD reactor and the voltage source will be connected to the DBD reactor. OSA will be connected to FBG, ASE light source, and OES. By using different grating length that I have mentioned earlier, wavelength shift will be observed and peak intensity will be measured. What will be expected on the result? Varying FBG grating lengths will cause temperature to differ in the reactor. Measuring intensity reveals that longer grating create peaks while shorter ones make it more uniform. Low voltage results in small shift in break wavelength and subtle intensity changes. High voltage leads to large shift in break wavelength and significant intensity changes. That's all from me. Thank you.